Hi, welcome back.
Hi.
Hi. I'm going to apologize now if I get a little sidetracked. I'm sick today, so the voice might be a little weird too. So today we're continuing our logarithmic functions. We're going to continue graphing them, but this time the only thing that we're going to be given is going to be the equation. We're not even going to be given a table of values. And so the trick for us today is to figure out how to graph these things when all we're given is the function. And I think I want to add one little piece in here. Okay, I'm going to put a D right there. I'm very sorry for that messiness. I'm going to call it a D. I know, because I don't want it to be a B for this, because this is the B for base. When we've been doing transformations, this has appeared to be a B, but I don't want it to be confused with the B for base. Okay, so I'm just going to flip it around. It's going to be a D today. Okay, but it's serving the same function. All right, so let's review our transformations really quick. We're not going to use them a whole lot, but we want to kind of have them in our heads. This is controlling what kind of transformation? Vertical. Vertical stretch, vertical compress. One more. You just stop right there. Flip, vertical flip. If you guys didn't get this, more copies have shown up. They're right here in the front. Out here, right there, inside the parentheses, but outside of the X controls what kind of thing? Horizontal. Reflect and stretch and compress. Perfect. This in here controls horizontal moves, horizontal shifts, horizontal slides. And this out here controls vertical up and down slides, shifts, things. Yes. Beautiful. All right. In order to graph these functions by hand, which is what I'm asking you to do right now, you need two things. The first thing you need is the vertical asymptote. And the vertical asymptote is given at x equals negative h. Okay? So whatever that h is, including its sign, take the opposite of that. Unless we have a y reflect. There's an exception. If we have a y reflect, you're going to grab y. You're going to grab h exactly as you see it.
So it's like negative 5, and there's a negative in front of the x. It's going to say it's negative 5.
Yes. So let's show a quick example of this. I have, this is my example, and we want the vertical asymptote, written as x equals some value. Normally it would be a positive 3, but because I have this y reflect, it is a negative 3. Okay? Easy enough? Yeah. Okay, good. The next thing that you're going to need are 3 points. Okay? We want to grab 3 points. As easily as I can get this to make sense, the 3 points you want are, I want to know information about where the base of the logarithm's exponent is negative 1, the place where the logarithm's base is 0, and the place where the logarithm's base's exponent is a 1. Okay, I'm going to try to clear this up. So we have log base something of and then some s, right? Some values. We're going to grab those values here, and we're going to set them equal to the exponent that we're after. In this case, a negative 1. In this case, a 0. in this case a 1. Wait. The base to those exponents. We're grabbing all of this. Okay? Let me run some numbers. Let me run some numbers to get this to make sense, because this is really kind of the most challenging bit to it. Okay? And this is just to help us find some points. And what I'm doing here is I'm trying to be really tricky about which points I'm selecting, so that I select the nicest looking points that you can do without needing to grab the calculator and just having it give you the graph for you. Okay? Okay. I want to do this one. Log of x plus 8 minus 4. I'm not writing the base. And so if I don't write the base is automatically assumed to be?
0.
How many fingers and toes do you have? 10. So if I don't write the base is assumed to be? 10. Okay. All right. So I know that I'm going to want to find base of the logarithm to -1 power, base to the 0 power, base to the 1 power. The base you told me was 10, so I'm interested in finding 10 to the first power. I'm interested in finding 10 to the 0 power. And I'm interested in finding 10 to the first power. Those are my 3 kind of major points. If I have a whole number base raised to a negative exponent, what do I do? Reciprocal. Yeah, I know what you meant, because you did this with your fingers. You flipped your fingers up and down. You're going to take the reciprocal of the base. The reciprocal of this base is 1/10. Yes?
Luis is going home.
Thank you. It's got a power of 1, so I don't need to do anything more. We're okay with that? Okay. Anything to the 0 power is?
1.
And then anything to the 1 power is? Itself. So these are the values that are of the most interest, and these are the values that I want to go in there. Because if I put these values in here, my results of that logarithm ends up the exponent of that original thing. Okay? We're all right with the big picture? Okay, let's crank out these numbers. Let's see what happens. I'm going to do this one first. I'm going to figure out where x plus 8 equals 1/10. Oh God, I have to deal with a fraction in an equation. Easy enough. I'm going to multiply by the denominator to get rid of that fraction. So I'm going to multiply this side by 10. I'm going to multiply this side by 10. Multiplying this side by 10 is going to get rid of that denominator, the thing I multiplied by. So leaving me on this side with a 1. Distributing out this 10 gives me 10x plus 80. I'm going to move the 80 over here to this side. So I have 10x equals negative 79.
Why negative 7?
Because I subtracted 80 from both sides. Thank you. And then I'm going to divide both sides by 10, leaving me with negative 7.9. And so I'm claiming that if x has a value of negative 7.9, then the thing inside the parentheses of my original logarithm becomes 1/10, 0.1. Okay? So let's do that real quick. So log of negative 7.9 plus 8. Okay? This is my original logarithm, and I just replaced my x value right here. Do that subtraction, and I'm going to get log of 0.1. 0.1 as a fraction is 1/10. 1/10 as an exponent is 10 to the negative first. From up here.
Where'd you get the 10?
from right here. So I had negative 7.9 plus 8. That became 0.1. I rewrote 0.1 as a fraction. And then, because of this law of exponents up here at the very top, I can rewrite that 1/10 as 10 to the negative first. So far, so good? Okay. Now the base on this logarithm is 10. And so now I have a match between the base of the log and the base of the thing I'm taking the log of. And when I have that match, the entire logarithm collapses down to just this exponent. Take a moment to digest that. Make sure that makes sense. This was our shortcut from day 1. Our shortcut that said when I have the log of some base to a base with a power, that this whole thing equaled the power. Remember that? Okay? So that's what I did here. And so now that thing equals negative 5. This is a y value. So the point I'm going to want to graph is negative 7.9 comma negative 5. And that's 1 point on my graph. That's 1 point on my graph. That's a lot of work. Admittedly, there's a lot of work. But I'm asking you to grab these points so that you can avoid all of this work. Okay? You agree with me that grabbing this value generates a value of x that then makes this value go inside of the parentheses of the log, which then lets me just grab this exponent to evaluate the entire log? You feel convinced of that now? Okay? All right, so now that you're convinced of that, I'm going to do these two using the shortcut of, well, because I made it that way. Okay? All right, so I'm going to figure out where this equals this value. Okay? And again, we're looking at this value right here. So x equals negative 7. Okay? So I'm claiming that at x equals negative 7, the thing that I'm taking the log of is 1. So this should now be 1, because I'm replacing the x in here with a negative 7. Okay? So I can go from here directly to here. The log of any base of 1 is 0. Leslie, we're okay with that?
Yes.
So this is negative 4, and my point is going to be negative 7, comma negative 4. I have 2 points so far. I'm going to highlight them so I don't lose them later. All right, I'm going to try to do this one with an even quicker shortcut. I'm looking for the place where x plus 8 equals 10, because I want these two things to match. Because when they match, my logarithm evaluates to this exponent up here. So in order for this to be true, x must be 2. And so I can go from this to this. Think that through. I used a shortcut. I said x was 2. If I put x is 2 in there, I get the log of 2 plus 8. 2 plus 8 is 10, so I get the log of 10. Well, since I'm not saying a base, the base is 10. So this is log base 10 of 10. I have a match between that base and the thing I'm taking the log of. Whenever I have that match, my result is 1. Okay, see my shortcut? And so my next point is going to be 2 comma negative 3. And now I have 3 points on my graph. And notice that that amount of work got shorter and shorter. Your goal is to get down to this amount of work for all 3 points. Okay? Yes? No? All right, let's graph this thing. I'm going to graph it over here in this little space. So I have 3 points. I need 4 bits of information to graph this thing. I need these 3 points, and I need the vertical asymptote. Here's your vertical asymptote. So my vertical asymptote is at -8, and then I have 3 points. So those are going to be the 4 things that I graph in order to sketch this out. I'm going to count by, I guess I'll count by ones. 1, 2, 3, 4, 5, 6, 7, 8. So here's my vertical asymptote. All right. My first point is at -7.9, which is really close to -8. And I'm at -5 with that. 1, 2, 3, 4, 5. So there, I graph this one. At -7, I'm at -4. 1, 2, 3, 4. I graph that one. And at +2, I'm at -3. 1, 2, 3. All right, so then my graph goes something like this. And this is f of x equals log of x plus 8, all that minus 4. Questions? Question? I'm looking around, just checking. We'll call it a day, let you guys work. All right, sounds good. Thank you very much.